Imagine Python receiving vehicle data. Temperature 105 degrees. Battery 10.8 volts. Speed 80 kilometers per hour. A human engineer instantly knows 105 is too high. Python doesn't. We have to teach it the rule.
Let's write Python's first decision. If, then a condition, temperature greater than 100, then a colon. If that condition is true, the indented line underneath runs. Temperature is 105, which is greater than 100, so we see warning printed.
This is an if statement. Python checks, is temperature greater than 100? If yes, warning prints.
Let's change temperature to 85 and run the exact same code again. This time, 85 is not greater than 100, so the condition is false and the indented line never runs. Nothing prints. That's the if statement working correctly in both directions.
But what about 95 degrees? Not critical, not quite normal either. Two states aren't enough.
Now let's handle three states instead of two. Elif means else if. It lets us check a second condition only when the first one was false. Python checks top to bottom. Is temperature over 100? No. Is it over 90? Yes. 95 is greater than 90, so we get warning. Order matters here. Python stops at the first true condition and never checks the rest.
elif lets us check a second condition. Now we have three states: critical, warning, normal, checked top to bottom. 95 lands on warning. And what happens if neither condition is true? That's where else comes in. It handles everything that didn't match the conditions above. So 85 degrees becomes normal.
We already know how Python checks conditions using if and elif. But what happens when none of those conditions are true? Let's test it. Our temperature is 85 degrees. Python starts at the top and asks, is 85 greater than 100? No, so it moves to the next condition. Is 85 greater than 90? Again, no. Now Python has reached the end of its conditions. That's where else takes over. Else means if nothing above matched, run this code. Since 85 is neither critical nor warning, Python executes the else block and prints normal.
But a vehicle isn't just temperature. What if temperature is fine, but battery voltage is dangerously low? Monitoring only one signal means missing another.
Same if/elif/else structure, but notice what's different. We're not printing anymore. Each branch assigns a value to temperature_status instead. That means the result doesn't just disappear on screen. It's saved, so we can use it later, combine it with other checks, or print it whenever we're ready. Let's check a completely separate signal the same way. Battery voltage. If it's below 11.5, that's a warning, otherwise normal. Now we print both stored results together. Temperature comes back normal, but voltage 10.8 is below our threshold, so battery comes back warning, even though temperature looked completely fine.
Instead of printing, we store the result, temperature_status. Now we check battery the same way. Battery, warning. Two signals interpreted independently. This is the bigger idea behind automation. It's not about collecting data, it's about turning data into decisions like pass or fail, normal or critical, continue or stop. But look at our code. We're repeating the same logic. Now imagine 50 signals: coolant, oil pressure, brake pressure. Copying this pattern 50 times isn't sustainable.
Let's bring everything together into one vehicle health monitor. Both signals get checked exactly like before. Then one final decision, combining them. If temperature_status equals critical or battery_status equals warning, either one alone is enough. The overall _status becomes check. Otherwise, everything's normal. Battery came back warning, so even though temperature is fine on its own, the overall verdict is check. That's the real value of combining signals. One bad reading is enough to flag the whole vehicle.
Let's combine everything into a vehicle health monitor. Temperature and battery, check together. One final verdict, check whenever anything needs attention. This exact logic shows up everywhere in engineering. Validation, diagnostics, test automation, monitoring. Is this signal within range? Does it pass or fail? But our code still isn't reusable, and it doesn't scale to real systems. Tomorrow, we package this logic into reusable functions, turning it into real automation code. If this helped, subscribe to our channel. It's free. Share it with someone who needs it. Code's in the description. See you tomorrow.